Hello, my name is Moses Ajay. In this video recording, I will be covering straight line graphs and correlation. And at the end of this video recording, you will be able to analyze and interpret data using straight line graphs. You should also be able to use correlation coefficient to predict relationship between two variables. Graph of straight lines. Now, in this video recording, I'm going to be showing you how you could convert equations to graph and how you could convert your graph to equation. Now, because we're going to be focusing on straight line graphs, this is something I want you to know. This equation y equals mx plus c. This is the equation of a straight line graph. This equation says that y equals mx plus c. Invariably, we could write this equation as a function and say y is a function of mx and c. So what this means is that here, as you could see this equation, y is a variable, x is a variable, m is a slope like a constant, and c is also a constant. And what this means, I'm going to be explaining this later on. Now, here y is a dependent variable, and x is an independent variable. Here our m is the slope, and our c is the intercept on y axis. Now, don't worry, this is limited to y and s. This could be a unit of quantity produced in food factory. This could be a particular ingredients that goes into that production. X could be a particular ingredient, y could be the total numbers of product that is produced. So we have made this simple to just use a simple line, a simple y and x function. And now, how do you calculate our slope? Now, our slope is defined as the ratio of change in y to that of change in x. So which means that when you draw your graph, you could look at the particular portion of that graph, watch out for change in y and also for change in x. Because it's a straight line graph, that will be constant, that will be the same throughout the graph, throughout the point you've plotted. Throughout the point you've plotted is going to be constant because it's a straight line graph. And your c, don't forget, is the intercept on y axis. Even if your point didn't get to that, if you plotted the graph and you don't have an intercept because of the point you've covered, you can actually extend that line to have an intercept on y axis. I'm going to show you how to do this later on. Now, this is a typical example just to emphasize on my explanation. Have a look at this graph. This is a straight line graph. Now, and this is our y axis, this is our x axis. Now you can see that when you draw the graph, this is where it cuts y axis. So this is an intercept. So this is where it crosses the y axis. This is an intercept. The value here is your c, where the line crosses the y axis. Now let's look at how to calculate our slope, our gradient, or our steepness. Now, these are several names that m could be called. Now, to find our slope, now I said earlier, it's going to be change in y and the corresponding change in x. Don't forget, is a corresponding change in x. Now we've taken a point from here to here, and we want to look for corresponding change. All you need to do is just draw a straight line from that end to where it touches the graph. So this are change in both. This is going to be a straight line drawn, and this is going to be another straight line drawn horizontally. Vertical difference and horizontal difference. That the ratio of the difference equals our gradient. We're going to illustrate it with an example. Now, predicting graph orientation with m. Now, with your m, with the slope of your graph, if you know the value of your m, if it is positive or negative, you can actually predict the orientation of the graph. Now, the one you have on your left is a positive gradient, and the one you have on your right is the negative gradient. Now, how do you know this? How can you easily remember this? Now, this is like putting your right hand from the right this is like using your right hand towards your left hand side. If you swing your right hand from right towards the left, from top to down, that is your positive gradient. If it is your left hand, you fling from the left towards the right downward, that will be your negative gradient. So I use the right for the positive gradient, I use the left, swinging the left hand downward from left to right. It gives you a similar orientation to that of negative gradient graph, and swinging the right hand from the right towards the left downward will give us the positive gradient graph. This is just a way of checking whether the graph you've drawn is correct or not. I'm going to show you this later on. Now, the very first thing you need to do when you want to plot your graph is to generate tables of value. Now, and when you generate your tables of value, the values you have in your tables will now be used to plot your graph. Now, and you simply draw a straight line through those points you've created, and that graph represents the graph of the equation. Now, I'm going to illustrate it with an example. Now, this is a typical example. We've been given a function y equals 2x minus 5. You could say this is an equation, but probably we'll say it's a function. It's a function because this is not 1 or 2, but let's say this is referred to as a function. Whenever you have y equals 2x minus 5, it's a function. Some people can call it equation, but you don't really need to bother about that. Now, what we want to do now is to plot a graph of y versus x. Now, we've been given this function y equals 2x minus 5. Without even drawing the graph, I could say that, I know you could tell me the orientation of this graph, because we could see from here, comparing this to the formula that I've given to you, the general formula that I've given to you for equation of a straight line graph. Now, I've given you a formula. Let me just go to that formula. This is the formula y equals mx plus c. Now, if you look at this, just try to memorize this. Y equals mx plus c. Now, if I go back to this, so you see y equals mx plus c. If you put that, if you put that beside this, now you discover that our m equals 2. So our slope for this function equals 2. Without even drawing the graph, we could actually say something about the function. Now our m equals 2, and our c will be what? Not 5, not 5. It's minus 5. Don't forget, it's minus 5. This negative sign is for this 5. It's minus 5. It is not 5. It is minus 5. So our m equals 2, and our c equals minus 5. Our intercept on the y-axis. So I expect you, after drawing this graph, to have an intercept of minus 5 on the y-axis. And again, calculate your slope and obtain 2 for me. So, but before that is just knowing the solution from the beginning. So now let's draw this graph together. Now we know we've been given, we want to draw the graph between 1 and 5. We've been told that we want to draw this graph from 1 for where our x equals between 1 and 5 for x. So we'll be given our x. Now our x values are 1, 2, 3, 4, 5. So that is the region of interest for this particular graph. Now, and we want to know what will be our y. All you need to do is to, if you want to know y that will be here, the y that will be here, that will be corresponding to 1 of x, is all we need to do is just to put 1 here. So you have to multiply by 1 minus 5. That's going to be minus 3. And for this one, put 2 here. So it's going to be 2 multiplied by 2, which is 4, minus 5 is going to be minus 1. Then for this one here, 3 x equals 3. 2 times 3 equals 6 minus 5 equals 1. For this one, 4 multiplied by 2, 8 minus 5 equals 3. And this one here, 5 x equals 5. So 2 multiplied by 5, 10 minus 5 equals 5. So let's look at how we could do that also in another way. Now you could do that by actually expanding your tables. Now, I'm bringing in the function. This is another way of doing it. This is the elements in the function now. We have 2s, that's the first element, and the second element is minus 5. You can see it's minus 5. I didn't just put 5 here. Please note this sign. It's minus 5. So we've put the elements in the function into the table. We've included the element into the function, elements in the function into the table. Now, don't forget this is our x, and we want to know what will be our y. So for this one, 2x, x equals 1, 2s will be 2. S equals 2, 2s will be what? 4. So this one is going to be 4. And when s equals 3, our 2s will be 6. When s equals 4, our 2s will be 8. And when s equals 5, our 2s will be 10. Now, for this one, this is not having s. S is not attached to this particular variable. It's minus 5. So it's going to be constant. So that is why it is even referred to as constant, the intercept on the y-axis. So everything here will be minus 5 because s is not attached to it. So all we now need to do is to sum them together. So we have 2, we have minus 5. You know, like I always explain, somebody is having £2 in the bank and is owing minus 5 in another bank. So the net worth of that person will be what? Minus 3 pounds. And that's the same thing for this one here. Is having 4 and is owing minus 5. The net worth of that individual will be what? Minus 1. And here we are, somebody is having £6 and is owing minus 5. The net worth of that person will be 1. Similarly, the net worth will be 3, and the net worth of this person will be 5. I hope you understand that. So we've been able to generate the values for our y, and we know the corresponding value of x for each of those values. Now we want to plot the graph. Let's go to the graph now. So we've been able to extract out from that table the value of our x. We've been given x before, so we've generated the values for y. Now we want to plot the graph. What we need to do now is to look at x. Now look at the graph. We've already put the scale there. So we have 1, 2, 3 to 5 there. So we want to plot the graph of this one now. So now, for when our x equals 1, don't forget this is our y-axis. Our y-axis is the vertical, and our x-axis is the horizontal. Now, when our x equals 1, this is 1. You could see this is 1 for our x. Our y equals minus 3. So you come here. You can see this is 1 for x, and this is minus 3 for y. So this is where they will meet. This is where they join together. So if you draw a straight line here for 1 of x and another straight line for minus 3 of y, so this is where the two lines will meet. So that is the point for first one, 1 of x minus 3 of y. You could see if you come to this point, if you look up along the x-axis is 1. If you look horizontally along towards the y-axis, it is going to be what? Minus 3 for y. And for the next one, I'm thinking if you could know, can you guess where this one will be? When s equals 2, our y equals minus 1. So I think you can guess right. What would that be? Well done. This is going to be where it's going to come. Yes, well done you. So it is 2 for x and it's minus 1 for y. And for the next one, 3 for x and 1 for y. Well done. That is great. Yes, you're right. It's going to be here. So that will be there. That is 1 for y. And for the next one, 4 for x and 3 for y. That is good of you. That is where it's going to come to. It's going to come here. So, and the next one is 5 for x and it is 5 for y. So this is where you have your 5 for y. So it's going to come there. So we've been able to plot, now the points have been plotted into the graph. All we need now is to use our ruler and draw a straight line. So we draw a straight line for that. So we have that. Now, from what I said earlier, now what is our M? What is our C? We know our M and C before. We know that our M is 2. We know our C is minus 5 by comparing the two together. You're right. Now you can see when you compare this and this together, you know our M is equals 2 and our C equals minus 5. We know that. But now let's look at the graph. Let's see if this is the same thing. Now let's look at the graph. When you look at the graph, we could see that our intercept is -5. We could see that that is good. Our intercept on the y-axis is -5. Please take note, I am not talking about intercept on the x-axis. I'm talking about intercept on the y-axis. So it's -5, which is corresponding to what we have in our equation. Okay. Now let's look at our hem. How do we calculate our hem in the graph? You remember the formula, delta y all over delta x. All right. So what we need to do is to look for a point on the graph that we can easily measure. I wouldn't go for this point because it's going to be difficult for me to predict what would this point be. I know somebody will say it's 5.5. Moses, we could do that. It's 5.5. But I want to save myself that stress. So I will probably go for this point because I know this is 5, or probably for this point because I know this is 3, or probably for this point because I know this is 1. So I've gotten my first point. You could take anyone. So my first point is here is 5. So what I will now need to do is to draw a line. So I draw a line. Now when I'm drawing that line, I'm also looking at the other end. I wouldn't stop here because I don't want to, maybe it's 2.4 or 2.3 or 2.5. No, I wouldn't stop here. I wouldn't stop here. Maybe it's 1.5. I will stop here in 2 or in 3 or in 1. So here for this in this scenario, I have stopped in 1. Now the reason why I stop in 1 is because when I trace this also this way, I could easily measure my what? My x. So you can see I could measure my x very easily. So you can see I could measure my x very easily. If I had stopped here, you discover that my x is going to be very difficult for me to measure. If you go down here, it's going to be 3 point something. I don't know. But if I stop here, this would be great. If I stop here, yes, I could measure my x. My x will be 4. If I stop here, my x will be 4. So you can see if I stop here, if I go this way, my x will be 4 and my x will be 5 also, which is great. So I could stop here. That would be a very good way to do it. If you stop here, you get the same answer. It doesn't really matter. So if you stop here, you will discover that your change in y will be between 3 and 5. That is 2. And your change in x will be between 5 and 4, which is 1. So 2 over 1 is 2. So your m is 2. Yes, that is good. Now let's look at it. Let's look at where we stop. We stop here. Now we just assume if you have convinced you, just stop. I'm sorry. Just let's take it again. So you draw the line. Now for your x, for your y, as you draw the line, you started from 5. You stop in 1. Now you know your x is 5 at that point. So which is good. We could measure our x straight away. All you need to do now is to look for what is your delta y. That's our delta y. Now you go on and look at what would our delta y be. Our delta y equals 5 minus 1. You could see this is 5 here, and you stop at 1. So 5 minus 1, that is 4. We've done that. That is delta y equals 5 minus 1. Now let's go for x now. So x, all you need to do is you don't need to stop yourself. Just draw a straight line from where you stop for y to the graph. So here, what's our delta x? This is our delta s, and it's going to be from 5 to 3. So our delta s will be 5 minus 3, which equals 2. And your hem would therefore be 4 divided by 2. That is your slope. Okay, that is your slope. That is your hem. Now, that is the same thing when we stop here. When I was explaining the other time, when I assume we stop here. So we also got 2. Because our change in y equals 2 and our change in x equals 1. 2 divided by 1 equals 2. So even if you stop here, you will still be getting the same thing. Just don't forget, if you stop at the negative section, this is now minus. So it's going to be 5 minus minus, and don't forget minus minus will be plus. So instead of saying 5 minus 4, it's going to be 5 minus minus, which is going to be eventually be 5 plus. You please take note of that. If you stop at the negative section, take note of your sign when you are adding or subtracting. Okay, so that's our hem, and our c, as we could see, is the intercept on the y-axis, which equals to minus 5. Okay, so it is as that simple. So you can go over this video again, and I think you understand. You agree with me. You understand this. And now, so let me just give you some advice and some pieces of advice on how to draw graph on graph paper. Now, if you are drawing a straight line graph on paper, please try to use as much as possible The sheet, you can't just draw a very small graph on a large sheet. Try to maximize the graph sheet. Now include your title. Don't forget. I always label the y-axis and the x-axis, very important. Now use a ruler. You are drawing a straight line. Use a ruler, place it important. And when you are choosing your scale, choose carefully. Choose carefully, depending on the available data. If the data does not fit the scale of 1, 2, 3, 4, as in the simple scale, you can go for multiples of 2, 5, 10, 20. Just make it simple for yourself. Go for the best things that make it easy for yourself. And at the same time, some datas can be in decimal places, like 0.01. How do you plot graph how do you plot that in graph? You could simply multiply all the datas by 100. You understand what I mean? Just trying to make it simple for yourself. But don't forget that when you're writing your scale, you need to indicate that you've actually convert those numbers. You've multiplied those numbers by hundreds just to make it easy for yourself. For example, if you have 0.1, 0.0, 0.01, 0.02, 0.03, 0.04, multiply everything by 100. You'll be getting 1, 2, 3. So it's easy to plot 1, 2, 3 on 4, 5, 6 on the graph rather than 0.01, 0.02. But if you are using that value, if you are using the graph to do some calculation, remember to divide also at the end of the day if you are getting your final answer by 100, so that you are using the same scale you have in the original data. That's my advice on the graph. And again, start your scale from 0. Now this is a typical example of what I've just mentioned. So the graph is too small, there's no label, no title, ruler has not been used, scale not appropriate. You could see 3, 6, 9, 12 is not really the best, because it's going to be very difficult to count this, to allocate this small holes to this number. It's going to be very difficult. So use appropriate scale of 1, 2, 3, 4, or multiple of 2, 4, 5, 10, 20. Make it easy for yourself. All right. And don't forget to include your graph. This is a typical example. Draw it neatly, and then we label y-axis and x-axis and the title of the graph. Okay, good. Now, this is a practice question for you. So try and look at it and then solve the problem. This is the answer for your help. Now here we are not giving the function, we are giving the data directly. Plot this graph, plot this data, generate from the graph we are going to obtain your hem, obtain your C, and get the graph of the equation. Please do not work towards the answer. When you get the answer, you come and check what you have here. Try and solve it, and this is what we are expected to have. Okay, now correlation. This is exploring the relationship between two variables. Now we want to know, there are several types, but we're going to be focusing on Pearson correlation. Now this is a measure of the strength of a relationship between two continuous variables. Now your correlation should be between 0 and 1. Now 0, no correlation. Sorry, your correlation should be no, your correlation could, let me make that mistake. Now it could be negative. Your correlation can be negative. You can have negative correlation, but because you have the sign will tell you whether there's inverse relationship or there's direct relationship. If it is positive, it tells us that there's a if it is positive, it is a direct relationship. Y is when y increases, S is going to increase, and when y decreases, S is going to decrease. Now that tells us a direct relationship. When it is inverse, it's going to be negative. Your correlation value will be negative, but you cannot get an absolute value that is more than 1. Okay, the absolute value for your correlation will be between 0 and 1. That's what I'm trying to say here. So when it is 0, there's no correlation. When it is 1 or minus 1, that tells us that it's a straight line. All points are on a straight line. It's a perfect correlation. Now let's look at an example. Now this is a straight line graph. This is also a straight line graph. So you could see, like I said earlier, remember what I said earlier, using your left and swinging downward towards your right. So you can see, and that tells us a negative correlation. Here, the slope of this graph will be negative. And look at the other end, swinging your right hand downward towards your left. So You swing your right hand downward towards your left. Now you will be having this type of orientation, and the correlation is +1. Now what that one is telling us in essence is that as your x increases, your y also increases, or as your x increases, your y decreases. For example, if it is 10 here and it is 10 here, so when it goes down to 2, it is also 2 here. So it's a function. It's telling us that relationship here. As your y increases, your s is going down. As your y goes down, your s is increasing. You could look at an example. 10 for x, your y here is around 1. At this junction, our x is 2. Here, our y is 10. So you could see from the value of your r, -1, and then for this one, when one is increased and the other is also increasing, that tells us our r is +1. Same for our slope. Now this is a formula for calculating Pearson correlation coefficient. So we're going to be focusing on Pearson correlation coefficient. Now, do not worry yourself about this formula. Nobody's going to be asking you to memorize this formula. Nobody's going to be asking you to if you are going to be asked any question that relates to this in the exam, for example, you'll be provided this formula. So all you need to know is to understand what this formula stands for. Now there are three elements in the formula: n, x, y, and then we have this r as the value for Pearson correlation coefficient. Now let's look at the formula. Let's try and look at the formula very well. Now our n is the number of the data involved. Our x is your x values and your y is your y values. Now, don't forget, your s could be, like I said earlier, could be amount of a particular ingredient, and your y could be the products. So try and make sure you are consistent with the use of your x and y. Okay. Now, how do you solve this problem when you have this? I think the best way to do this is to have an example where you agree with me. But don't forget that you need to identify, you need to understand what this formula stands for. This is telling us that after you've multiplied your x and y, this is summation, okay? Summation of your x and y. Here is summation of x, here is summation of y, and here is summation of x squared. Here is summation x, then square that value. Here is summation of y squared. Here is summation of y, then square the value. So you need to do this step one after the other. You see it's not something difficult. And don't forget, the square root sign is here and is applicable to all the data you have in the denominator. Let's look at this together. Now this is a typical example. You've been given a graph of x and y. Now for exercise, I'm giving you an exercise at this junction, and the exercise is plot this graph. Plot the graph of this data. Okay, plot the graph of this data and see for yourself the correlation, whether it's negative or positive, and see the relationship. If you want to go ahead, you can also get the function for this data. It's possible, because we've done that in the first session of this lecture. So what we are really interested in here is the correlation. So let's focus on that. So we'll be given our x, we'll be given our y. So all we need to do now is to look for the elements in that big formula, in that correlation formula. Look at the elements, all the elements inside this formula. So we need to find those elements out. Now we've discovered that in that formula we have xy. In that formula, our x is given, so our y is given, no problem. So in that formula also we have s squared. In this formula also we have y squared. So we know what we need. We need xy, we need s squared, we need y squared. So let's go back to the formula. In this formula we need xy. Our s is given to us, our y is given to us. We also need s squared. Our x is given to us. We also need y squared. This is just telling us to sum it together. Summation, this big E in the opposite direction. No, don't be intimidated by this sign. It's just asking you add them together, sum them together. Okay. So now we need xy, we need s squared, we need y squared. So when you're calculating your correlation, these are what you need: xy, s squared, y squared. Now according to this formula, there's other formulas that is slightly different from this. All you need to know, I'm not saying you should not use those formula, but try to understand what those elements are, and try to get that element from the data you've been given. But when we limit ourselves to this formula, we know that we need s, y, we need s squared, we need y squared. All right. Now, and then from here, from all of this, we could calculate our summation x. Don't forget, this is that big thing that says you should not be intimidated by. It's just telling you summation. So all we need to do for summation x is just to take our calculator and add all of this together. Then for y, we add all of this together to get summation y. Now for this, we know xy is a product of x and y. That's what it means. So 25 multiplied by 63, you get sy. Same for this, 35 multiplied by 68, you get it sy, and so on and so forth. Here is telling us s square, 25 square for this, and 63 square for y square, and 35 square for s square. So all we need to do is just to do that. And when we've done all of that, we now sum them together. We get summation sy, summation s square, summation y square. Now let's look at what we have. So this with x, y is 25 multiplied. If you take out your calculator now and do this to confirm, xy is 25 multiplied by 63, you get this. Now you could pause this video here to confirm. Okay, so and our s square is 25 square, and our y square is 63 square. That is 63 multiplied by 63. So the same for all of them. You could pause this video now and confirm all these figures. Okay, now we've done this, and what we need to do now is to look for summing them together. We know our n is the numbers of data. Now what did that mean? What is the meaning of that? It's just telling us what is the numbers of your hex. 1 2 3 4 5 6 7 8 9. So we have 9 of that. So our n is 9. I'm not saying you should count everything, please. It's just telling us the numbers of data. If you go back to the original question, it's telling us the numbers of cigarettes we smoke per day. No, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7, 8, 9, 10. Sorry, 9. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, what am I counting? This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, it's 9. Sorry. So that's 9. So we know that our n is 9. Now, our summation x is adding all of this together. You add all of this together. That is the summation x. Summation y, add all of this together. Summation sy, add all of this together. Summation x square, add all of this together. Summation y square, add all of this together. And don't forget, and summation s square add all of this together. Summation s square, add all of this together, and summation y square, add all of this together. Now, we also need to know what is our summation x square. Now, which is this one? Summation s is this one. Square it. That is this. Okay? You can see summation s square. That is 425 square. And summation y square is 542 square. This value here. Square it. Because these are the elements. All these are the elements we need in that formula. So once we've done this, all you need is these are the same element you have on the previous slide. And this is the formula. Now, numerator elements. N, 9. Summation xy. Summation sy is this, 24640. Minus summation x, 425. Multiply by summation y, 542. So this is what we have in the numerator. On top here, this is what we have. Okay, this is what we have. And that will give us, multiply this one, 221760. Multiply this one by this one, 45 multiplied by 542. Get this one, then subtract them. When you subtract this one from this one, you get minus 8590. So we've been able to get what we have in the numerator. Doing it this way, we make it simple for us. Now let's go to the denominator. Denominator, we have the square root. Don't forget, square root n, 9. Summation of x square. Our s square is this one. Summation of s square is this one, 24525. And minus summation x square. Summation x square. This is summation x. Okay, square that. 425 square. Okay, multiply by 9 and summation of y square. This is our summation. This is our summation of y square. 33188. 33188 minus summation y 542. Then square that. So what do you have next? Square root. You've multiplied this one by this one. You've taken this one away. Okay. So 9 multiplied by 24525 minus 425 square. You get this. And 9 multiplied by 33188 minus 542 square. You get this. So you multiply by themselves, you get this. Then find the square root of that. You have 14057.48. Now that is our denominator. We need to divide that to get our R. To get our R, numerator divided by denominator. Don't forget that negative sign is there. So take that along. Don't leave it behind. Divide that by what you have here. Then you have your R to be minus 0.611. Say that that's our R. That tells us the relationship between X and Y. It's negative. We know the orientation. We know how that graph will look like when we draw it. And we can also say that when our S is increasing, Y is decreasing. And it makes sense. So if we go back to the question. When the numbers of cigarette smoke per day increase, numbers of year live increases. It makes sense. The more the cigarette, according to this research, so this is not about what I'm saying. So it does make sense in terms of that. We could apply that to food production and so on and so forth. So we know the relationship. Now we know that there's negative relationship between the numbers of cigarette smoke and numbers of year lives. So that's the final answer for our R. R equals minus 0. Don't forget that negative sign is very important. Now, I need to explain this. We need to be careful with the way we use correlation. Now, in this module, in this course, we are not going to be going into details. But in real life situation, at your place of work, when you are analyzing customer data and so on and so forth, you can encounter some complexity. For example, now look at this cluster here. Now, in the case on our left, R is very close to 1, but the relationship is not a straight line. So we need to analyze in details what is happening here. More information or analysis could be performed. We need to perform more analysis. Now, there might be some two groups, or let me say two subpopulation in these groups. That were not identified before. You may have a group of people here. Maybe this might be adults. This might be maybe children, for example, or school people, university students, or this might be aged people in the society. This might be young people in the society. This might be female. This might be male. So we need to know what is going on here. You can see a cluster, and if you look at the correlation, it's very high, very close to 1. It looks like a straight line, but it is not. And also on the right hand, there's a single point that may want us to believe that this is a straight line. If you draw this from here, it will appear to be a straight line. So we also need to look into this. What is happening? This might be an outlier. So we need to look at what is happening regarding this. We need to investigate further when you encounter this problem. That's why we need to plot. When you plot the graph, in addition to what you've computed using the Pearson correlation coefficient, you also need to that graph will give you a clear picture of what is going on, and that will enable you to analyze in details what is going on. Okay, so like I said, low value does not indicate that there's no association between the two variables. Now, if you have a low value, if you have very low value, it doesn't mean there's no association. The association might not be linear, might be not linear, might be, for example, you might have a relationship where you have this look like a curve, and on the left hand side, it also look like a curve. So here, this is not going to give us a correlation that is very close to 1, but there's a relationship. You could see there's a relationship between the two, but the relationship is not linear. So you need to look at what is happening in real life situation. When you plot the graph, you have that understanding the distribution of your data. So this is a practice question for you. Now you want to calculate your R to show the correlation between the shelf life of your product or of a product and its initial bacterial loading. So this is very related to food, looking at the correlation between shelf life and the logs of bacteria, the total viable count. And this is what you're likely to get. There's your answer. And please draw your graph to visualize this. So in this lecture, we've covered data analysis using straight line graphs. And we will also cover correlation coefficient to predict relationship between two variables. Please don't forget, if you have any question, do not hesitate to contact me. You are just an email away or a phone call away from us. So my email address is there. Thank you very much.